Hi there, this is Dr. Thomas again, math instructor at Lawson State Community College, and I want to talk to you about factoring by grouping. How should you know that you should factor by grouping? You should consider it when you have 4 terms. You should always factor out the GCF first whenever possible. Consider rearranging terms to get a common binomial factor. Okay, let's get started. So let me give you an example of a common binomial factor. Let's say you had the problem x squared times x plus 5 minus 7 times x plus 5. If you will look at this as a term and this as another term, the common binomial factor is x plus 5. This is considered to be your greatest common factor because this is what you see in both terms. Therefore, you will factor out that common binomial factor x plus 5, and once you take out x plus 5 out of each term, if you take out x plus 5 out of x squared, x plus 5, you only have x squared remaining. If you take out x plus 5 out of minus 7 times x plus 5, you only have minus 7 remaining. Therefore, you've just factored using a common binomial factor. Let's move on. Let's say we had x cubed plus 7x squared plus 2x plus 14. We do not have a GCF for all 4 terms. You should consider factor by grouping because you have 4 terms. 1, 2, 3, 4. When we have 4 terms, we normally group 2 terms together. If you would notice, the first 2 terms happen to have something in common. And you may see some people maybe put a parenthesis around the terms that they're grouping. I normally do not, but you can always group them using a parenthesis. So let's look at the first 2 terms. X cubed plus 7x squared. The GCF out of just those 2 terms that we group is x squared. Once you take that x squared out, what will give you back x cubed plus 7x squared? It'll be x plus 7. X squared times x plus 7 will give you x cubed plus 7x squared. Moving on. 2x plus 14. What is in common? A positive 2. I always put a plus here. Always put a plus, or if it's you're supposed to be taking out a minus, put a minus there. Some students forget to put the operation here. So make sure you put your plus or your minus here. Once you take out a 2, your remaining factor is x plus 7 again. So this is what you want. You want to see a common binomial factor. As you see, we have the same x plus 7 showing up. This is what shows you that you are on the right path, that you are working this problem out correctly when you end up with a common binomial factor. So out of this term and this term, x plus 7 is your GCF. So you take that common binomial factor out And if you took out x plus 7 out of x squared, x plus 7, you have x squared. If you took out x plus 7 out of 2 times x plus 7, you have a positive 2. So, this is the answer. Moving on. Let's say you had x cubed minus 2x squared plus 4x minus 8. Always look to see if you have a GCF. We do not have a GCF for all 4 terms. Therefore, you need to consider factor by grouping since you have 4 terms. Let's group the first 2 terms together. Now let me say that sometimes you will have to rearrange terms. The cases that I'm giving you right now, so far we've only dealt with polynomials where we could group the first 2 terms together and the last 2 terms together. So let's group the first 2 terms together. The GCF is x squared. If you take an x squared out, you will have x minus 2 remaining. Let's see if we get this same x minus 2 over here. What's in common with 4x minus 8? A positive 4, actually. Positive 4. 4 is the highest number that can divide into 4, x, and 8 evenly. So we take the 4 out. You also have an x minus 2. Therefore, we know we're on the right track because we see that we have the same binomial, common binomial factor. So we're going to take that common binomial factor out. X minus 2. If we take that x minus 2 out of both terms, if we take it out of x squared times x minus 2, we're left with x squared. If we take out of 4 times x minus 2, we're left with that positive 4. So therefore, the answer is x minus 2 times x squared plus 4. Moving on. Let's try x cubed minus x squared plus x minus 1. No GCF because 1 doesn't have an x, therefore we do not have a GCF here for all 4 terms. But since we have 4 terms, let's consider factoring by grouping. Let's try to group the first 2 terms together and the last 2 terms together. Looking at the first 2 terms, x cubed and x squared, what is the GCF out of just those 2 terms? X squared. If we take out an x squared, we are left with x minus 1. Now notice we have an x minus 1 over here. That's what we want because we see that we had an x minus 1 here. So really what you could factor out is a positive 1 because we want that x minus 1. Nothing else is in common with x and 1 other than 1. Now you can see that we have a common binomial factor. And let me reiterate that normally we take the GCF out first out of all terms that we see, but we're factoring by grouping. Once we group terms together, we take the GCF out of just those terms we group together. But normally we will factor the GCF out of all terms. Okay? So normally we don't just factor the GCF out of maybe 2 or 3 terms. We factor out all terms except when we're factoring by grouping. Alright, so we're not finished yet because we got the GCF here. Now it's x minus 1. Take the x minus 1 out. And what are we left with? We're left with the x squared. And we're left with the positive 1. Therefore, the answer is x minus 1 times x squared plus 1. Moving on. One more. 3x squared plus xy minus 12x minus 4y. We do not have a GCF here as well. For 3x squared, xy, 12x, 4y. Nothing's in common. But we do have 4 terms, so we should consider factoring by grouping. Let's just consider factoring the first 2 terms together and the last 2 terms together. Let me say again, sometimes you will have to rearrange terms. That means that if 3x squared plus xy does not have something in common, you may have to pair 3x squared with minus 12x. And you may have to pair plus xy with minus 4y. Let's just try it, rearranging this. So factoring this, the GCF out of this will give us 3x, and then we have x minus 4. Over here we can factor out a y, and we have x minus 4. So look at that. Actually did not turn out so bad, because we have a common binomial factor here as well. So we'll take out the x minus 4, and we're left with 3x plus y. So for this particular problem, you could have done it both ways. I rearranged the terms, but you don't have to for this particular problem because it worked both ways. So I'm going to say rearrange terms if needed. In this particular case, you could have factored out a x. You could have factored out an x here because that's the GCF, and you could have factored out a negative 4. So let's do that the other way as well. So you can see you can do it both ways for that one. So this is the same problem as before. Let's just group the first 2 terms together and let's factor out an x. And we'll have 3x plus y left. Over here, notice that you can factor out a minus 4. And that'll leave you with 3x plus y. Because that negative times that positive must give you that minus. So you couldn't put minus there. Because when you multiply that negative times everything in here, you have to get back negative 12x minus 4y. So again, you have 3x plus y, that's the common binomial factor, times x minus 4. Basically, multiplication is commutative, so this answer is the same as x minus 4 times 3x plus y. Now that concludes the video on factoring by grouping. I hope that it helps.